This conference will now be recorded.
All right, Math 211 students, this is the section 3.1 extra examples that we didn't get to in class. Remember, this section is over finding critical numbers and then absolute maxes and mins using algebraic processes. Plus, we also learned how to identify local and absolute maximums from a picture. So to find the critical numbers of a function, you have to remember that critical numbers are defined as when does f prime of c equal 0. In other words, if the derivative at a certain value equals 0, then we know that that's a possible critical number. For us, it is a critical number, but will it be a max or min is the question. And then f prime of c does not exist. So if there's somewhere where you don't have a function value for the derivative. So to figure this out, we need to first of all take the derivative of this. So we're going to take the derivative of this function right here. So this is h prime of u would be 6u squared minus 6u minus 36. I would set that equal to 0 to figure out if there's a c value that works. I would also factor out a 6. And that's going to factor into u minus 3 and u plus 2. So my possible critical values are -2 and 3. And those are going to be the only ones because this is a polynomial and so is the derivative. There's no place where the derivative is not going to exist. It's continuous and differentiable everywhere. So the critical numbers are, in order from least to greatest, -2 and 3. Okay, so let's do one that's a little bit more interesting. We did some fraction ones in class. We talked about the absolute value. Let's do one that's a product rule. So this is big F of x equals x to the 3/5 times x minus 4 squared. So if we want to take the derivative, we're going to have to do the product rule. And that means we're going to do first times the derivative of the second, which is going to be a chain rule and a power rule kind of with a function inside. So 2x minus 4 chain inside is a 1. And then plus the second times the derivative of the first, which is a power rule. So that'd be 3/5 x to the -2/5. So let me just clean up the way this looks. So we have a 2x to the 3/5 and an x minus 4. And on this one, we have 3/5 x to the -2/5 and x minus 4 squared. Now, to be able to find your critical values here, you're going to need to factor out that GCF like we've been practicing with. So I'm going to, and this is where it's hard for people when there's rational exponents involved, you always pull out the smaller of the two. So we're going to pull out -2/5 because that's the smaller of those two powers. And we also have an x minus 4 in common. Now what that's going to leave us with, we have to be careful here. This is going to be a 2. When you pull something out of a factor, you're really dividing. You're really doing x to the 3/5 over x to the -2/5. You're dividing this out of this. So when we divide, remember we subtract our exponents. So this is actually x to the 3/5 minus -2/5. It ends up being x to the 5/5, which is a x to the first power. Sorry, not a 1. So that means we're just going to have an x left inside here. Now the x minus 4 is gone. On this guy, we're going to have the 3/5 still there. The x to the -2/5 is out, and we'll have an x minus 4 left over. So to figure out what our critical values are, first thing I'm going to do is I'm going to move that negative exponent guy to the bottom. So it's going to be x to the 2/5 down here. I'm also going to work out this, so I might do that on my scratch over here. So this is 2x plus 3/5 x minus 12/5. I'll probably get a common denominator of 5 for that, so that's 10/5 x plus 3/5 x minus 12/5. So this is actually 13/5 x minus 12/5. And if you wanted, you could pull out the 1/5 that they have in common, and then that would just be 13x minus 12. But it's just as easy just to solve it as it is. So when you have a denominator in your derivative that has an x in it, you have to make sure that you also include critical numbers where the derivative does not exist. So that means in this denominator, f prime of c does not exist if x equals 0, because if we plug that in, that's going to make us divide by 0. The other thing is f prime of c equals 0 on the tops, so we need to set those equal to 0 individually. So x minus 4 equals 0 would be x equals 4, and 13 over 5x minus 12 over 5 equals 0. We would add over our 12/5 and multiply by, that's not a, sorry, my pen is going nuts, 13 over 5. And then we would multiply by 5/13 on both sides. So you get 12/13. So my critical values or critical numbers are anywhere that my derivative equals 0 or my derivative does not exist. So in order from least to greatest, that would be 0, 12/13, and 4. All right, so that is that one. Okay, so let's look at what we have left. I believe we only had one on 4. Yes, we had part B. So the directions here are to find the absolute maximum and absolute minimum values of f on the given interval. And we are looking at we're looking at t minus cubed root of t on -1 to 4. So what you have to do for these is you have to first of all find all your critical values and see if any of them are in the interval from -1 to 4. And because it's absolute max and min, it could also be the endpoints. It could happen at -1 or 4. So once we find all of our critical values and we have our endpoints, we plug them into g of t, the actual function, not the derivative, because absolute max and min has to do with the biggest or smallest height on the actual function, not the derivative function. So the derivative is just being found just to get those critical numbers. So if we take the derivative of this, I'm going to rewrite this as t minus t to the 1/3. That would be 1 minus 1/3 t to the -2/3. Just to make my life easier, I'm going to move that to the bottom, and I'm also going to eventually get a common denominator because I want to compare this as one big fraction instead of two parts. So if I make this common denominator, I would get a 3t to the 2/3 minus 1 over 3t to the 2/3. So notice we have that as our pieces. So now we want to set each of those equal to 0 to see where we are actually having our issues. So if you set the top equal to 0, that's going to be 3t to the 2/3 minus 1 equals 0. So that's going to be 3t to the 2/3 equals 1. Divide by 3. That's 1/3. And then this is to the 2/3 power. So now when we flip that to get rid of the 2/3, you're raising it to the 3/2. But because you are turning something that was a cubed root into a square root, we have to remember to throw on plus or minus. That is really important. Anytime you flip a fraction to get rid of the power, if the bottom ends up being even, you need plus or minus. So this would be plus or minus the square root of 1/3 cubed. So I need to cube that first. So that would be square root of 1 over 27. We're going to try to break this up. So this is plus or minus 1. Square root of 1 is 1. And 27 would be a 3 on the square root of 3. And then if I rationalize that, that would be 1 times square root of 3 over 3 square root of 3 times square root of 3. This ends up being plus or minus square root of 3 over 3 times a 3, which would be 9. So two of my critical values or critical numbers are negative square root of 3 over 9 and positive square root of 3 over 9. The other one comes from the denominator. Now, luckily, this is equal to 0. You're just going to realize that t equaling 0 would be a problem because that's the only way that could equal 0 since there's no plus or minus. So 0 is also another critical value. So now here comes the part where you're evaluating whether or not this is an absolute max or min. But I just do these in order. So f of -1 is the smallest because all three of these are in the interval -1 to 4. And then we would do f of negative square root of 3 over 9, f of 0, f of square root of 3 over 9, and then we would also do f of 4, which is the other endpoint, except these are all g. So let me fix that. It's very easy to just say f of x all the time. So we're plugging these back into the g function. Now 0 is easy to plug in. That's just going to be 0. -1 is also easy to plug in. -1 minus the cubed root of -1 is -1. So that's -1 plus plus 1. So that would be a 2. Actually, no, sorry, I said that backwards. It's better to write it out. This is -1 minus the cubed root of -1. So it's going to be -1 plus 1. So it actually ends up being 0 as well. 4 would be 4 minus the cubed root of 4, which is not a nice number. If we plug in square root of 3 over 9, that's square root of 3 over 9 minus the cubed root of square root of 3 over 9. So we're going to have to work out what would that be. So that's going to be square root of 3 over 9 minus, I would rewrite it as square root of 3 over 9 to the 1/3. And honestly, if it was me, we probably wouldn't give you one like this on the test. So I'd probably use my calculator. But because this one's kind of messy, you'd have to get that to be, that's going to be 3 to the 1/2 over 9, and they're all being raised to the 1/3. So you get square root of 3 over 9 minus 6th root of 3 over cubed root of 9. Yeah, this is pretty messy. So I would just type this one in on your calculator. And when I did that, I got, I want to say -2 square root of 3 over 9 for the first one. And then for the negative, when I plugged it in, it comes out positive. So yeah, I mean, like I said, that's probably not one we could ask you on the exam because there's a lot going on with the evaluation there. So the deal here is that we need to figure out which one of these is the biggest and which one is the smallest. So this is 0, 0, and that's negative and that's positive. So the only question is this come out negative or positive? Cubed root of 4 is going to be really tiny because the cubed root of 8 is 2. So no matter what, this is going to be 4 minus something smaller than 2. So this is going to be bigger than 2. So that means that this one right here has to be the absolute minimum because it's a negative. So my absolute minimum value at -2 square root of 3 over 9 of, I should say of there, at x equals square root of 3 over 9. So that one's definitely the absolute minimum. It's the smallest y value we have. Now the question is this or this larger? So let's get our calculator out and do a comparison. So if we have square root of 3 times 2, and then we divide that by 9, notice that's 0.38. Let's do the one with its 4 minus the cubed root of 4. So we're going to do I'm going to do 4 to the 1/3 power, since that's easier on this calculator. So that's cubed root of 4. We need to make that negative since it's negative cubed root of 4, and then add 4 to that. So notice that's 2.41. So this is definitely the largest one. So we have an absolute max value of 4 minus the cubed root of 4 that occurred at x equals 4. So the absolute max occurred at the endpoint and the absolute min occurred at one of the critical values. And like I said, this one got really messy in the calculations. So, I wouldn't stress about that too much.